Hi, welcome back to the Mentored Engineer. In the last two episodes, we looked at the law of cosines for modeling the cylinder geometry, and we looked at solving the simultaneous equations. Today, we're going to make a mathematical model of our equations and get that into MathCAD so that we can use it, and we'll check it using our SolidWorks. All right, so let's go to MathCAD. Well, I've already inputted pictures of our videos. On the left you can see where we did the law of cosines, and on the right the law of sines. We're going to be focusing on this one today, and I want to make sure that I mention this, is that in this equation here for the moment arm, it's actually a sine, not a cosine. You probably realize this pretty quick once you get in there and notice that. So I ask you for forgiveness on that, and just want to let you know. Alright, so the first thing we want to do is specify our angle theta here. Alright, and right here it's drawn at about a negative 10 degree position, so I'm going to keep that, and we'll put in that theta equals to 10 degrees. Alright, so downward 10 degrees, but it's drawn negative, so that's why it doesn't have a negative sign there. Now, let me make this bigger for everybody here so we can all see it. Now when we have input variables like this that change, I love to put them in a green border here. Highlight the region here and just make it green so that when I'm scrolling through this, boom, I can see it very easily. Alright, so let's specify another couple variables from what we gained last time. The first one is this lowercase delta equal to the arctangent of d1 over d2. And then here, b1 equals the sum of the squares of d1 and d2. So let's go ahead and do that. Now, since d1 is very small, we expect a very small angle here, somewhere around 2 degrees. 2.9, exactly. Alright, and then b here, it's going to be slightly more than d2, just because d1 is so small. And it is, look at that. Okay, so the next thing we're going to do is we're actually going to solve the angle A. Alright, so the angle A is going to be, it's going to be 90 degrees minus theta minus delta. Okay, so 90, and you got to make sure you put in degrees, otherwise it's going to think it's radians. And we'll put in minus theta and minus delta. Okay, so let's look at SolidWorks here. We can simply put in an angle here, and we're going to use these two construction lines, and equals 77.1 degrees. Alright, which is exactly what our angle was here. So let's count that as a win in our book. The next thing we want to do is calculate the length of this length here, which is A, and it's also equal to the length of the cylinder. So we're just going to bypass the step where it says A and just put the length of the cylinder in. And we're going to use this equation here. Since we know A, we know C, and we know B, let's calculate lowercase a. So we're going to do that. I'm not going to use a solve block since we know everything here. I'm just going to throw everything under a square root sign. So C squared is equal to this vertical dimension, which is d3. So it's d3 squared, whoops, plus b squared, we didn't change the name on that one, minus 2 times c, which is d3, times b, times the cosine of a. That is equal to 46.04 inches. All right, let's go over to SolidWorks and we'll measure it. 46.04. Wonderful. It's looking good so far. So the next thing we're going to do is solve this equation for the variable c, and c is the angle from there to there, and it'll allow us to get our moment arm here. We are going to use a saw block for this one because I don't feel like flipping that whole equation around just to get the cosine of C all by itself. Now we want to make a guess at C. From the geometry, it just looked like it was 45 degrees. I don't know, somewhere between 30 and 60 degrees. So I'm going to put in 45. Alright, so I'm going to use D3 squared because that's the one opposite of C. And using my Boolean equals again for a solid block. That is going to equal LC squared plus B squared minus 2 times LC times B times the cosine of C. Alright, and let's just hope this works. Oh, it did not want to work here. Alright, it's saying the variable is not defined above. Okay, so here's the problem. We got LC and a capital C there. Look at that. Hey, I was pretty good at my guess. 46 degrees. Let's now go check that in SOLIDWORKS. Alright, 46.04. We have another winner. Okay, now the last two things we're going to do is we're going to use this to get our moment arm, and we need this to get angle delta. Alright, so let's do the moment arm first. The moment arm is equal to B times the sine. This is where I wrote down the wrong thing in the last one. And that's going to be the sine of C. And we can check that. And that's 28.47. Let's go to SOLIDWORKS, check that real quick. And that'll be the dimension between here and here. 28.47. Okay. Okay, so the last thing we're going to do is check get our overall angle delta, which will be equal to C minus our delta angle. So capital delta equals 43.14 degrees. Now let's go to SOLIDWORKS and check it. So that'll be right here, 43.14 degrees. Excellent. So we've got winners all the way around. Now one thing I would recommend doing is checking this in a couple different configurations. With SOLIDWORKS, it's fairly easy. Alright, so right here all I'm going to do, I'm going to change this 10 degrees to 5 degrees. Alright, let's do our moment arm here. If we get this one right, we probably got all of them right. 27.47 inches. Okay, so all we do here is change this to 5 degrees. And 27.47 inches. So we have a winner. Thank you for joining us this time. I hope you learned something and that it was valuable. I hope you're beginning to see that MathCAD is a wonderful tool for calculating things. In our next video, we're going to look at solving the forces on the pin and the force of the cylinder. We'll also look for a worst case condition as well. Thank you for joining us today. Have a wonderful day.